Thank you, Portico. I noticed that. How is the microphone? I have a sense that it's weird today. Yeah. Let's try. Okay. Now it's super quiet, right? Is this better? I will, yeah, I also want to know, I'm guessing you couldn't hear me when I had it on that other setting. And unfortunately, the audio is the hardest part as far as the setup. It shouldn't be, but it is. Because of the way that I'm bringing stuff in. But yeah, is the microphone better now? And okay, good. Sadly, the way that everything is connected up today means that every word I say, I hear in my own ears. And I don't know that I can fix that. So I may just go forward with that. That was not the intended behavior. Anyway, hello everybody, welcome. Welcome to an adventure. I am Anthony Wright, the Community Collections Archivist here at Virginia Tech, and you might know me on the internet as Rogan27. This is my Wednesday show where we look at things from the archives and special collections here, most often things that I have not seen. So, yeah. Yeah. I'm going musicless today because I cannot hear my voice on a couple second delay in my ears after I say anything. So, enjoy the music. Let me know if it gets wonky or weird or anything goes wrong with it, because I won't be able to hear it today. And that'll be, this setup will not be the one that survives, because it's closer, but not quite right. Hey, every weekend is an adventure, an archival adventure. Join me. I constantly am trying to improve it, and I'm trying to get it so that I can have basically everything go through OBS, so that I have easy, quick control. Unfortunately, this time, Sterling, welcome. It's good to see you. This time, in setting it up, yeah, I think I need a virtual cable for my computer, because I need to be able to split the microphone input from the desktop audio, and presently I can't, which is part of why I was late today, because I was trying to work that out. Anyway, how about we figure out what we're looking at today? I know It is the James Robbins Randolph papers. And that's about all I know. I don't know much about them because I don't take a peek in advance anymore. I have a student assistant who is prepping the episodes for me. And so I get to go in sight unseen and do the unboxing, and you get my honest reaction to what things are, because I haven't seen them before. Also, Sterling, thank you for the follow. How about we pull up the finding aid? Actually, before we do that, I have an order of operations, don't I? Also, I should just say, hello everybody. It's a reaction video. It is indeed an unboxing reaction video. Obi-Wan Pez, it is great to have you here. Thank you for joining. Lord Portico, Shadows of Life, Key Squared, Sterling, Conciliance. It is great to see all of you. Anybody who is lurking, welcome. Whether you're on the V2L Studios channel or the Rogan 27 channel, I enjoy having you here. We do start every episode by paying attention to the history of the institution where this is being produced, because, hey, we're looking at archives and history, so we should pay attention to this stuff. Virginia Tech acknowledges that we live and work on the Tutelo and Monacan people's homeland, and we recognize their continued relationships with their lands and waterways. Sorry, 1 second. There we go. Thank you, Hannah. We further acknowledge that the Morrill Land Grant College Act of 1862 enabled the Commonwealth of Virginia to finance and found Virginia Tech through the forced removal of Native nations from their lands in Western territories. We understand that honoring Native peoples without explicit material commitments falls short of our institutional responsibilities. Through sustained, transparent, and meaningful engagement with the Tutelo and Monacan peoples and other Native nations, we commit to changing the trajectory of Virginia Tech's history by increasing Indigenous student, staff, and faculty recruitment and retention, diversifying course offerings, and meeting the growing needs of all Virginia tribes and supporting their sovereignty. Virginia Tech acknowledges that its Blacksburg campus sits partly on land that was previously the site of the Smithfield and Solitude plantations, owned by members of the Preston family. Between the 1770s and the 1860s, the Prestons and other local white families that owned parcels of what became Virginia Tech also owned hundreds of enslaved people. We acknowledge that enslaved black people generated wealth that financed the predecessor institution to Virginia Tech, the Preston and Olin Institute. And they also worked on construction of its building. Not until 1953, however, was the first black student permitted to enroll. Through Inclusive VT, the institutional and individual commitment to APROSIM that I may serve, in the spirit of community, diversity, and excellence, we commit to advancing a more diverse, equitable, and inclusive community. We were just talking about theories of sovereignty yesterday. And yeah, there it is. We acknowledge. Let's see, which action word? Supporting. Yeah, we support the sovereignty of Indigenous nations that whose land we're on. That is the word. There are so many action words in there. I'm going to pull up the James Robbins Randolph papers, finding aid, so that we can just find out who the heck was this guy. Why do we have his papers before we dive into start looking at some documents? If you're unfamiliar, because I don't always show how I get there, this is the website where our finding aids live. It's called Archival Resources of the Virginias. It's a site that includes finding aids from all across Virginia and West Virginia. Not every cultural memory institution has their stuff in here, but most of them do. And so if I pick Virginia Polytechnic Institute and State University, and let's type in the name. It helps if I type on the right keyboard. Two computers in front of me. Yeah, I get confused on which one I'm typing in. The James Robbins Randolph papers, dated 1922 to 1961. So let's find out what it says in here. And this is just a thing that bugs me, so I'm gonna take out this. I'm gonna make it so it doesn't highlight the search terms anymore because it makes it harder for me to read it. Usually it will highlight where they appear, but I don't need that. Biographical note. So this is a little bit of like a short biographical sketch that the archivist or one of our student assistants, one of our grad assistants, whoever happened to process these papers, prepared this biographical sketch to help researchers, to help orient people to what this collection is, so that they can tell if they might be interested in looking at it. James Robbins Randolph was an instructor in mechanical engineering and physics, was born on August 4th, 1891. His father, Lincoln Strother Randolph Sr., served as a professor of mechanical engineering at Virginia Polytechnic Institute, and the younger Randolph received a bachelor's degree in mechanical engineering from VPI in 1912. After obtaining a master's degree in physics from Harvard in 1921, Randolph taught physics at Simmons College and Mount Allison University from 1920 to 1922, was a physicist for the National Bureau of Standards from 22 to 25, then taught mechanical engineering at George Washington University and Rhode Island State College from 25 to 30. From 31 to 43, Randolph was an officer in the U.S. Army Reserve Ordnance Department and in active service from 42 to 43, attaining the rank of major. Randolph returned to teaching in 1943, serving successively in the physics and mechanical engineering departments of Western Maryland College, Rensselaer Polytechnic Institute, the Pratt Institute, the Fairleigh Dickinson College. Wow, he taught at a lot of schools. I believe all of them are East Coast. I don't think I see any like Midwest or West on there, but that's a lot of places he taught. Randolph maintained memberships in the American Society of Mechanical Engineers, the American Physical Society, the Army Ordnance Association, and the American Rocket Society. In 1947/48, he served as editor of the Journal of the American Rocket Society. He died on February 4th, 1969, and apparently we even know he's buried at Riverside Ceremony in Springvale, Maine. It's interesting to see which details get put in to this short biographical sketch. Like, I probably, if I had written this, would not have included where he was buried, personally, but I can see why some people would, and it's not wrong to include it. The opening sentence, like I would structure it differently if I had written it. Like I would leave out instructor in mechanical engineering and physics, because that assumes that you already know that about him, and it's like James Robbins Randolph, yeah, the instructor in mechanical engineering and physics. At least that's how I read it, but that could also be useful for somebody. I mean, you find that information out later, but you had someone walk in just as I was about to come on screen. Of course. I mean, that's standard. And Shadows of Life, welcome back. I hope that you are enjoying your lunch. Anyway, we have these papers, materials such as notes, calculations, writings, both published and unpublished, and correspondence. Let's see. One of his particular interests during World War II was the subject of mental mobility, the ability to effectively adapt to rapid and extreme changes. Randolph actively researched and promoted mental mobility as a means of combat, or a means to combat Germany's Blitzkrieg war strategy. Interesting. It contains his research file on the subject, as well as published writings from Field Artillery Journal and Cavalry Journal, as well as a typescript draft of his unpublished 1920s sci-fi novel, The Neighbor World, with an introduction by Goddard. Cool. Yeah, so how about we start looking at some documents? That's not a document. Well, it depends on your definition. But when I went to library school and we were learning about what is a document, the stream notices reminded you to get lunch. Hey, I will be thankful for that. When I was in grad school and we were discussing what the definition of a document was, we explored the concept of the documentantelope. Is an antelope a document? Hint, the answer is yes. So the table is also a document. Exactly, Key Squared, yes. To be fair, we did have a whole stream of documents of wood. We did. They weren't even veneers. They were just very thin sections of wood, slices of wood, cut to show the different grains and textures. Is it me, or is that just super out of focus? I'm gonna switch to manual focus and then back to autofocus and see if it helps. It could also be the monitor I'm looking at. Let me know if it's out of focus for you too. Thankfully, because I have assistants preparing for this now. My assistant, who I will call them by name if they want me to, but I don't know if they want me to. So for now, they're my assistant. Filled out some highlights. Sterling, yeah, thank you for noting some highlights for me to look at so that I don't get buried in strange ledgers that we can't actually figure out what they mean, or things like that, which we've done before on stream. I'd prefer other things, but yeah, thank you. Kingston Rocket. I do not know what this is, so I suppose we'll find out. You can see this was a spiral notebook, and the spiral has been removed. That's because those will rust and are not good for preserving the document. Oh, the Kingston Rocket. I see the neighbor world. Can we go to Mars? Scientific American, August 1928. And then I'm guessing these are page numbers. So I think this is a notebook. Rather than so it talks about the neighbor world. It mentions the neighbor world here, which the finding aid said was his manuscript. Let's see, the neighbor world, including introduction by Goddard. Accompanying the typescript are summaries, appendices, and illustrations for the book, as well as the first section of an unpublished sequel. The finding aid doesn't tell me, so we're going to explore and we'll find out what this is. All right, page 1, velocity increments, 4 and 2, upper section, blast off. trying to remember what B is. So we got lithium, hydrogen, but what's B? Anybody remember your chemical or your periodic table? Boron. Lithium, boron, and hydrogen? Okay, so it's lithium dihydroborate. Yeah, thank you, Key Squared and Shadows of Life. I didn't remember boron. I remember a lot of them, but I didn't remember boron. And I did not know how the names would combine together to form the name that this is saying. But anyway, lithium dihydroborate. Again, something to do with blast off. I'm not sure what that middle word is. Post blast off, possibly. Oxygen, setback shells, electric arc rocket. So it looks like possibly a research file related to the book, or I don't know. We'll explore, but this is the table of contents. You have the periodic table on your wall, Shadows? Well, and so I'm thinking just based on this, and we can definitely go to page 5 and find out. It looks to me like that is not being used in rocketry, that it is an outcome of blast off, that it is I don't know. I don't know the word I'm trying for. A side effect of blast off. Okay, so we've got calculations here for velocity increment. Orbital velocity equals the square root of GR equals the square root of 32.2 times 4,000 over 5280 equals 2.04 over 4.93 difference miles per second, I'm assuming. Byproduct, that's the word. That's the word I was trying for, thank you. R is radius, thank you. So square root of gravity times radius. I would also guess that it's Earth. If anybody wants to check to be sure, is the radius of Earth roughly 5,280 miles? Escape velocity is the square root of 2 times gravity times radius. So escape velocity is twice orbital velocity. For Mars, multiply by the square root of 0.38 times 42 over 80. So multiply by 0.447. I like that it's not just the formula, but it's also worked out, because I can see the formula and my brain says, yep, that's a mathematical formula. It doesn't really mean anything to me. I'm like, yep, the square root of gravity times radius. But then when you actually see the square root of gravity times radius calculated out, that makes more sense to me. Like looking at the difference between, or the the note about for Mars, multiply by square root of, like, it, multiply it by this formula, but then reduces it down to just multiply it by 0.447. That super useful for me as just like getting some sense out of what's written here. Mars orbital is 2.21 and escape is 3.12, difference of 0.91. Earth orbit mean 93 times 10 to the 6th. Eccentricity 0.0167. Earth perihelion and aphelion, as well as Mars perihelion and aphelion. Velocity in orbit. I hope that the math fans, I hope that this is interesting for you. Like, to me, it's a bunch of numbers. So, okay, Earth, Mars, orbit. Is this a calculation for an orbit that would be a single body orbiting around both Earth and Mars? Because wouldn't the only way for that to actually be possible, the orbit would have to also just be an orbit around the sun, because they're not always on the same side of the sun. Physics, yes. Yes, Sterling. This is orbital mechanics, and velocity and rocketry, but somewhere in here there's physics too. Velocity increments, transfer orbit maybe. Oh, okay, that would make sense, because otherwise I was like, it would just be a circular orbit. So if this is an Earth to Mars transfer orbit, that makes more sense as far as why. Oh, you keep having to get up and do work. No, it's fine. What is A in this case? 2 times A equals 94.5 plus 128.3 equals 222.8. A is 111.4. Velocity squared, I'm guessing, v squared. Gravity times mass plus momentum. 2 over r minus 1 over a. Yeah, I would have to look up what some of these variables are to work out for myself what it is, just because I'm not used to doing orbital mechanical calculations. But this is just basic algebra. Given the equations as they're written here, I don't see anything that goes beyond basic algebra. I do like algebra. I'm not great at arithmetic, but I like algebra. Let's see, upper section. Yeah, I'm not sure what all of this is. This is payload calculations for the rocket, I assume. Ooh! It's a little drawing of a rocket. I don't know why. I think it's fun. It would help if he noted the units, but clearly he assumed he'd know what that meant. Yeah. A is distance, since he's subtracting it from r, but the distance of what? You couldn't tell. Average separation? Yeah, I don't know. So I don't understand. 24 cans. He's got cans. What? I wonder. This is not the first time I saw cans mentioned, but I don't know. Why that is the unit of measurement. But the liquid oxygen and hydrogen portion is apparently 24 cans high. And then the next section down, I don't know what's in it, but it is 90 cans high. And then at the bottom is where you have the cabin and the bunk room, which apparently is 14 cans. I don't know what can stands for. But it is an interesting rocket design because, oh, Portico, thank you for the self-care. I will definitely drink some water. And it's interesting to me because the actual like cabin is down right on top of the main engine at the bottom. And if you're familiar with like actual rockets that were built, the place that the people were is like up at the top, because usually like the nose of the rocket was where like the crew capsule was. And like if you look at NASA rocket launches, the rear sections, the lower sections, get jettisoned during takeoff as they burn through all the fuel. So having all of the fuel like up at the top with the crew cabin and stuff down at the bottom is an unusual design. Let's see, blast off. Upper sections. All right, so this is the lithium hydroborate, or dihydroborate, post-blast off. Gives 1,820 tons, a 2.77 mile per second delta V. I don't know what a capital I sub S would be in this sense. Equals 306 according to Bell's pocket data. M equals E. Is that M equals E raised to the power of 2.77 times 520 over 306 times 32.2? Which is just, sorry, it's been a while since I did maths like that, and having a number raised to the power of a calculated fraction of that sort just took me for a loop for a second. But anyway, M ends up calculating out to 4.45. Frozen cans. What is this whole can theory? I'm really curious. Let's see if I can find out. Oxygen tankage. Interesting. There's room outside the frozen cans. Is this like a bulkhead type separation system like you would see on a ship? The mass is a logistic formula because it's leaving propellant behind. Yeah, and that makes sense. It just took me a second to like realize that that fraction was what it was being raised to the power of, was the exponent. Pressure at bottom of each layer of locks at 30 grams. Wow. Lots of calculations here. It's just a very weird way to write it, yeah. Setback shells. Let's see, the first 2,000 feet per second is obtained by a gun in which acceleration is 30 g. Blast off from there is at 10 g. Pressure in liquid oxygen tanks is 240 psi, and then drops to 80. Make these tanks strong enough for 80, then put shells around them to take the other 160. Cabin also has a shell around it to carry the extra setback at high acceleration. All shells are made in 6 sections with flange at end held by explosive bolts. Shells are dropped when no longer needed by firing these bolts. When rocket leaves gun, there's a panel before, I don't think that's panel. There's a pause before blastoff starts. In this pause, the pressure shells around the liquid oxygen tanks are dropped. Liquid oxygen tanks are dropped when empty. Cabin shell is dropped after blastoff. This action is made automatic. Yeah, constant missing units. Okay, this is really an interesting description of how the rocket is meant to work. So the cans themselves, as they empty, are intended to fall away, and like explosive bolts fire, and they just get popped off the rocket as it's in blastoff, which it's not a terrible idea. I think it would be complicated because you couldn't guarantee that you're shedding mass evenly around the entire rocket. There's too much opportunity for something to go wrong. Whereas like the Saturn V's and things like that, they shed spent rocket stages just all at once, and it just drops off, which means that they're shedding equally. So talking about having each of these little cans, like a stack of cans, and as they empty, they get blown off the side, that's weird. And I think it would be hard, I think it would open up too many opportunities for a failure state. But it's interesting. Electric arc rocket, spaceflight, May 1961, page 111. Okay, so this is, I think, referring to a magazine article. No. I'm not sure what the first word is, but jet recently tested for 47 hours. Weighs only 3.5 pounds. Tungsten composite cathode and liquid-cooled copper anode. Thrust level, some calculations. Kingston Rocket. Sigma delta V equals 12 times 4.5 blast off miles per second. No. Sigma delta V equals 12 and 4.5 blast off miles per second. I'm not sure what the parenthetical there is. I don't think it's actually meant as a multiplication. but possibly it is. I'm uncertain. Anyway, assumed parts to accelerate equal 100 tons, 270 tons hydrogen needed. Average weight is 47,000 pounds. To 12 times 5280, so they need 63,400 feet per second. Acceleration for 1 pound thrust, time to accelerate. Time to accelerate to 63,400 feet per second is 63,400 times 470,000 over 1 times 32.2 times 3,600 equals 257,000 hours? This must be, that must be the calculation for, accelerating to the velocity needed to do the, Earth to Mars transfer? I'm guessing? But also, how many days is 257,000 hours? Come on, Internet. 29.31 plus years. 29.32 years, if you round it. So, if I'm interpreting this correctly, it would take his rocket a long time to get to Mars. Confused, but that's fine. These are somebody's notes, and a lot of it is calculation. But lithium and magnesium data from International Critical Table. Some more little sketches. I think this is a research file, honestly. If I'm looking, so the very front of this, it's labeled, it's noted as Kingston Rocket, but it references the neighbor world. And then it's all this stuff about different rocket fuels. There are notes with calculations about different types of rockets. I think this is a research file for his novel. And he was actually doing the calculations for what it would be. Here's the technology, and here's the forces involved, and the amount of time it will take, and stuff like that. I think that's what this is, just looking at it, that this is a research file for a hard sci-fi novel. If you're unfamiliar, hard sci-fi is a genre term that just specifically means it's a science fiction novel, or it's a subdivision of science fiction where all of the scientific elements are grounded in actual scientific theory, calculation. It's hard science. This is actually possible, even if we haven't done it, but the math says that we can, or as opposed to a more fantastical science fiction where you get things like space magic, like warp drive, that theoretically, though, now is possible, but still theoretical. There's a theory for how it could be done, but our current science says it's not actually possible given the way physics works in our universe. But they have figured out how it would be possible if it was possible. So Not today, Tantaros, but close. Next week. Magnesium, lithium, alloy, cabin details. This is neat. I'm gonna flip through some more because this has been rocketry, less about nuclear physics, which I suppose I should pay attention to because that was, sort of the point of today. Since I will not be here next week. This is going to be the final episode for September, which is why we're doing nuclear physics today, because I've been doing nuclear physics the final episode of each month. Can a physicist's solution of? Wait. This is something from Scientific American, August 1928. And I think we're only getting part of the title there. Let me see if I can put 2 pages there. Yeah, that makes more sense. Can we go to Mars? A physicist's approach to a fascinating problem, the solution of which is, however, far away. Let's see. Yeah, much more grammatically satisfying that way. Indeed. I'm actually going to zoom out. No, I don't need to. It's just the title that spans 2 pages, being very strange. I'm not going to read the whole thing, but we'll get a sense of... Interesting. The plan is theoretically sound. The editor makes no apology for publishing the accompanying article. It is not a Jules Verne story, nor an H.G. Wells story, nor even one of Dr. Hacksaw's secrets. It is a physicist's conception of a method for getting close enough to Mars to see what Mars is really like. The article was first submitted to several laymen for opinion. They voted against it. It was then sent to several physicists. These favored publication. In itself, this may have some significance. Mr. Randolph's plan cannot, of course, be realized at present. He says so himself. The manuscript was submitted to Professor R.H. Goddard, Department of Physics, Clark University, famous for his experiments on high-speed rockets, with the request for a public statement. Professor Goddard replied as follows. According to recent press notices, interplanetary transportation must remain impossible until atomic energy can be obtained and controlled. This attitude is, however, much like that of the scientists of 30 years ago, who declared that an airplane could not operate unless the force of gravity could be neutralized. If atomic energy were available, it would be a very convenient means of propelling an interplanetary rocket. Atomic energy is not, however, necessary, as an interplanetary flight is possible with means even now at our disposal. This is set forth in my article in the Smithsonian Miscellaneous Collections for 1919. If a propellant of high energy content, such as hydrogen together with oxygen, is used with high efficiency and in the proper way, an interplanetary flight is possible in a rocket that is neither tremendously bulky nor unwieldy. A rocket using a low energy propellant and operating inefficiently would, on the other hand, be impracticably large. The technique of such a flight constitutes a most interesting problem in physics, and one to which I have given considerable thought for many years. In the light of the conclusions I have reached, I can say that, although Mr. James R. Randolph's article, quote, "Can we go to Mars?" May read like romance, it is nevertheless thoroughly scientific, and while not telling the whole story, it gives a good picture of what an interplanetary rocket must be like. That's a really good review from Goddard. This sort of thing is delightful to read, as now a century later controlling atomic energy is routine, and it turns out to be largely useless for space travel, and we found other ways instead. Yeah. So let's see what Randolph had to say. It looks to be like a 3-page article, so I'm probably not going to read the entire thing. If you want to seek out to read the entire thing, it was published in Scientific American in August of 1928. The caveman looked across the river and wondered what was on the other side. Before long, he learned to build rafts, and later canoes, so that he could go there and see. The Norsemen looked out upon the broad Atlantic and wondered what lay beyond that gray ocean. Presently they built ships in which they could go there and see. Thus, man has spread himself all over the surface of the earth, and within the past generation, he has learned to fly through the air as well. And even the bottom of the ocean is yielding up its secrets. Today, man looks through his telescope at the other members of the solar system and wonders what is there. Will he ever be able to go there and see? Several of these heavenly bodies might repay at least a passing visit, should such a thing prove possible. The moon, too, is airless for anything more, but would be interesting to look at more closely than is now possible. Also, its invisible back portion would be worth seeing. Venus and the other outer planets, Venus and the large outer planets hide themselves behind dense veils of cloud, but there is a possibility that Venus might prove habitable for man. Well, sadly, the dreams of 1928 didn't pan out for Venus. But of them all, Mars presents the most interesting possibilities, and would probably be the first visited. Its skies are generally clear, permitting an easy view of the surface, and this surface appears to resemble our own in some respects, although in others it is very different. There is a possibility that men might be able to live there, although scientists are far from agreement on this question. And over all this surface is a network of fine, dark lines, the canals of Mars, which many people believe are the work of beings having intelligence comparable to our own. None of the other theories advanced to explain them have proved satisfactory. At least in the case of certain of these canals, even a flying visit might settle this question beyond a reasonable doubt, and would show whether or not there really are people there. The space between the two planets is devoid of air, or any other kind of matter. Hence, there is only one way in which such a trip could be made. A projectile of some sort would have to be thrown off from the Earth with sufficient velocity to clear the Earth's attraction, and would then have to be directed into an orbit that would touch the orbit of Mars at the time Mars got to that particular point of it. Then its velocity would have to be reduced so that it could be captured by the planet and become a satellite. Such it would remain for about a year, at the end of which time its speed would have to be increased, returning it to its own orbit and thence back to the Earth. Thus, the projectile would have to be able to change its velocity in a vacuum, and at the start, it would have to attain a velocity of 7 miles per second, as that is the velocity needed to escape the Earth's attraction. There is only one device known to science at the present time with which these requirements could be met. That is the high-altitude rocket invented by Professor Robert H. Goddard of Clark University. The shells from the largest naval guns have a muzzle velocity of little more than half a mile per second. The Goddard rocket is now in a stage of development corresponding to the small airplanes built by Langley. Small rockets have been built to test the principle that would be employed in constructing one to reach very high altitudes. The theory has been proved sound, and it has been shown that the problems to be encountered in going from these to large rockets capable of infinite range are no more serious than those involved in the design of huge transatlantic liners. When was Titanic? Engineering difficulties may be looked for because of the enormous size of the machine, and the cost will be very great, but the plan is by no means impossible. Yeah, this was after the Titanic, so the mentioning it's no more complicated than building a transatlantic liner. We don't have a great track record there. I thought maybe I was going to have to drop a historical terms, but yeah, it's been okay so far, yeah. Strange as it may at first seem, the Goddard rocket, or any rocket for that matter, works just as well in a vacuum as in the air. In fact, it may work even a little better. So the rocket would not have to come up to full speed while in the air, and the changes of speed required after leaving the air entirely behind could readily be made. Yes, but they're very costly. They're easy, they just cost a lot. Yeah, changing trajectory in vacuum. What is the... I forgot the term. I'm sure some of the other space enthusiasts around know the term I'm thinking of. But no, it's gone. Drop it in chat if you know. The word I was looking for. This fact has been proved by experiment. It can be readily understood, however, when the principle on which the rocket works is understood. This is the law known as Newton's third law of motion, and states that to every action there is an equal and opposite reaction. For example, if you are standing on an unmoored boat and walk toward the shore, the boat will drift away from the shore. The air has nothing to do with this. In order to start your body forward, body forward, you have had to give it a push. This push, acting backward just as much as it does forward, causes the boat to move in the opposite direction. Again, when the powder explodes in a gun, its pressure again. You haven't talked about the powder exploding in a gun. Did I miss that? Anyway, when the powder explodes in a gun, its pressure drives the bullet forward. But this pressure acts backward on the gun as well as forward on the bullet and causes the kick of the gun. In a rocket, there's no bullet, but the gases are expelled downward with high velocity, and the kick drives the rocket up at rates of acceleration which could be nicely controlled. The Goddard rocket differs from the ordinary rocket, much as a modern turbine differs from a hurdy-gurdy or flutter wheel. It works on the same principle, but it has been designed for the highest possible efficiency and power output. Some of the latest rockets use liquid fuel, whose nature is being kept secret, but the earlier ones used smokeless powder. In these rockets, the powder is confined in a strong steel chamber, capable of resisting the pressure of the explosion. And the gases are ejected at the lower end through the expanding nozzle. This nozzle resembles those used in steam turbines, and is designed to give the highest possible velocity to the gas. In some experiments using smokeless powder, this velocity was found to be 8,000 feet per second, while more recent tests indicate that velocities as high as 12,000 feet per second can be obtained. All right. Anyway, it continues, and he describes his rocket. There's even illustrations. Interesting. But we have spent a while on this Kingston Rocket folder, and there's more. There are more things in this collection. This is not all. So I should move on. If you want to hear the rest of that article, again, Scientific American, August 1928, or read the rest of that article. I suppose if you have somebody read it out loud to you, then you would be able to hear the rest of that article. Thermodynamics, rocket and comet calculations, isothermal expansion in nozzles. These are all very interesting things that you've pointed out as highlights. Let's look at some thermodynamics, because that should be physicsy, right? When the things were about nuclear bombs, it was very easy to tell that they were high energy physics. And when they were about nuclear reactors, it was easy to tell that they were about high energy physics. I think thermodynamics is, isn't it? Anyway. Is there a date on this? This is Thermodynamics 1, 1963, and no date. We have a university notebook, quadrille ruled. It looks like we've done a photocopy of the cover of this one. I'm guessing the cover was acidic, and they chose to photocopy it and get rid of the original. James R. Randolph, The Foxhole, Sanbornville, New Hampshire, Thermodynamics 1. I don't think this is a study notebook because he was a professor by this time. So let's see. Let's see what it shares with us. Normal nozzle with normal condensate. With supersaturation. Nozzle with normal condensates with supersaturation. And we've got a table of some sort. I don't know what most of this is. Interesting. Antilog. Coordinates means that the number is the log if it's something from zero. Distant from zero? Let's see what we can learn. Newark Evening News, Tuesday, February 21st, 19-something. 19-something. Mongols, first target of solid fuel rockets. What? By United Press International, contrary to some belief, solid-propelled rockets are hardly new. That is, unless you consider the discovery of America itself new. Wow, my watch is just very busy sending me notifications today. Around the year 1300, some enterprising Chinese people concocted and launched a gadget they called a fire arrow, and promptly seared the daylights out of their Mongol enemies. The fire arrow was simply a tube loaded with a gunpowder-like substance. Thank you for dropping some historical terms notes. Yeah. Crude as it was, this invention was the first solid-propelled rocket and the granddaddy of some of America's most potent ballistic missiles. And I don't think there's technically anything super objectionable here, but it is bordering on problem with not having the word people after Chinese. But that's more like this would not have been in any way an insulting way to refer to Chinese people or Mongols when this was written. Today, having Chinese without the word people would generally be frowned upon. Let's see. Cruise it was. This invention was the first solid-propelled rocket and the granddaddy of some of America's most potent ballistic missiles, including the Navy's submarine-launched Polaris. The rocket's red glare, described by Francis Scott Key in the Star-Spangled Banner, also was a solid-fueled missile. But this branch of rocketry fell upon black days when American, German, and Russian scientists began developing liquid-fueled rockets in the early 20th century. liquid fuels, it was discovered, developed a greater specific impulse, a scientific term for the measurement of energy available from a propellant. This generally holds true even today. Needs more mobility. All American and Russian space satellites have been boosted by liquid-fueled rockets, generally modified versions of ballistic missiles developed primarily for military uses. But one problem with liquid-propelled military rockets is defending them. It's one thing to set up a big rocket and aim it at an enemy. It's quite another to cart the missile and its volatile fuels from place to place to avoid being hit. More mobility was needed. American scientists found solid propellants stuffed delicately into a rocket casing in firecracker fashion the best possibility. Solid fuels have been developed with the idea that they must be easily handled by field troops, most of whom have had little technical training. The Polaris, possibly America's most renowned nuclear weapon, became a solid-fueled missile for this reason. Naval experts decided that handling dangerous and explosive liquid propellants aboard nuclear submarines was altogether too great a risk. Army has Pershing. The Army has come up with its Pershing, a solid-fueled missile that scientists believe troops can handle easily and move quickly. The Air Force soon will begin test flights of its Minuteman, an intercontinental ballistic missile fueled by solids that will allow it to be carted around the countryside on railroad cars. The Air Force also is developing an air-launched ballistic missile called the Skybolt. Okay, that's the first one of these that I've never heard of. It will be solid-fueled to give it the mobility necessary for launching from airplanes. The National Aeronautics and Space Administration, NASA, and the Air Force have a cooperative development going called Scout, a rocket made inexpensive because it uses solid fuel. Scouts will be used in space probes and in launching small Earth satellites. NASA already has ordered studies for supersize solid-fueled rocket boosters it claims would be far more powerful on a weight-for-weight basis than existing liquid-fueled rockets. These studies are to be completed in 6 months. Under this project, temporarily designated simply 3059, scientists will delve deeper into more exotic solid fuels, including those which can be developed from energy-laden lithium compounds. Most solid-fueled missiles presently being flown in the United States use nitroglycerine, nitrocellulose, ammonium nitrate, ammonium perchlorate, and plastics such as polyurethane. Okay, that list right there, there's some problematic chemicals in. So nitroglycerin, super volatile. Oh boy, that explodes really easy. Which I guess, if you're making rockets, you want things that explode, but wow. Ammonium perchlorate is, I don't know. I read that one and I was like, I know that one. And my brain said, is that a Superfund site chemical? But I don't know. I don't know if that's one of the chemicals that cause such environmental pollution or not. But certainly not a great chemical to work with for health. I'm gonna look it up. Let's see, inorganic compound with the formula ClO4, colorless or white solid that's soluble in water, powerful oxidizer. Combined with a fuel, it can be used as a rocket propellant. Its instability has involved it in a number of accidents. mainly used for solid fuel propellants. Perchlorate itself confers little acute toxicity. Okay, it's sodium perchlorate. Wait, sodium perchlorate has a chronic exposure to perchlorates, even in low concentration, has been shown to cause various thyroid problems. As it is taken up in place of iodine. So I knew there was something with perchlorates, and it is not specifically ammonium perchlorate, it's just perchlorates generally, that if there's enough repeated exposure, they can cause health problems. Chlorate, ClO4, somehow not the most toxic oxidizer. Yeah, somehow not. Is ClO4, would that be just perchlorate? Is that the chemical formula for the perchlorate portion of the name? Perchlorate acid, or perchloric acid. Gotcha. Yeah. Yeah, okay. Okay, where was I? The greater mobility of solid-fueled rockets also may grant scientists a cherished dream, the firing of space shots from the most advantageous spots on Earth. An official of Aerojet General Corporation said recently that such space rocket launching at sea are just around the corner. I wish I knew what year this was from. In general, the folder was labeled 1963 and no date. I know this is from the Newark Evening News, Tuesday, February 21st, 19 something. I would guess 63 if February 21st of 1963 was a Tuesday. But I don't know for certain. Let's see, Feb 21, 1963 was a Thursday. So this is not 1963. I'm guessing it would be 61 then. Yeah. So it'd be 61. Most likely. I suppose technically it could be 67. It's either 61 or 67. Those are the only two years in the 1960s where February 21st was a Tuesday. Had a couple of family friends who worked in the silos back in the Air Force. They were basically taught, if you see red mist, run as fast as you can in the other direction. That's off gas from N2O4. Nitrogen perchlorate? Which, if that just sounds dangerous. Interesting. Sorry, I was just flipping through just randomly to see if anything caught my eye before poking at other things in the collection, because, you know, we're getting towards the stated end time. And I saw this title, Sunburn as a Weapon. A mirror for solar power in space. Let's see. A mirror for solar power in spaceships is described and pictured in Astronautics, February 1961, page 16. It is 7 feet in diameter and weighs a half a pound. I don't know what that word is. Zeroid? I don't know what that first letter is. This one. Something pressure, 5 psi. Cone pressure, 0.01 psi. Yeah, it looked like zeroid to me too. I'm not sure. Possibly an uppercase, but none of them make sense. Even an uppercase I doesn't make sense there. Maybe it's just a misspelled period pressure, but it also doesn't look like a letter P. I'm not sure. Surface metallized mylar GT Sheldall Company. Heat from such a mirror is infinity times d over f squared. That is a very complex calculation to me. I could probably understand it if I spent enough time with it, but at first glance, I'm like, oh, this is too much for me. If f is also 7 feet, the mirror shown will give 7,220 degrees R. For any other desired temperature, d over f equals t over 7,220 squared. It looks really similar to the, so this is a capital I in his handwriting. And it looks quite similar. It's the same basic letter form, but without the cross. So his capital I has a cross through it. Huh, it's very strange. Zeroed. Yeah, I don't know. I thought maybe spheroid, but no, I don't think that's it. But something pressure, 5 psi, cone pressure, 0.01 psi. What is, I don't know what he's specifically describing. Anyway, if we needed to know, here's the thing about archives. Can I look back down? Your inner notebook nerd is having a gay heart attack now. I can also like zoom a little bit or get it positioned so yeah, in this case, if this was a very important passage that I needed to figure out what that word was, we have some clues. So we've got the rest of the notebook. We could go through and search for letter forms as written by his hand to see if we can figure out what letter that actually is. We know it's at the start of a sentence, so it's most likely a capital letter. We know that it is formed almost the same as his capital letter I. But does not appear to be a capital letter I. So it might be, we would need to think of cursive and what capital letters are formed similarly to a capital letter I. The other possible way to track it down would be find a copy of Astronautics from February 1961 and find out what he's talking about. So it's specifically talking about a mirror for solar power in spaceships. And then he goes on to give dimensions for it. Presumably the dimensions he's noted here appear in the magazine. And so we could probably find out what that word is by finding a copy of that magazine. I love how their equation notation is absolute robot perfect. Their handwriting looks like someone drew with their nose. And honestly, this handwriting is not hard for me to decipher. It's just an occasional letter where, like, maybe it's like a capital J or a capital Q, or like one of the ones that doesn't really get used a whole lot. So it's a T. It's a capital T. Because here again, capital T, table. I don't know why that one is a capital, but as soon as I saw it, I was like, yep, that's a capital T. I don't know what toroid pressure is, T-E-R-O-I-D, but that was a capital T. So, is that a word? It's not a full word. It might be an abbreviation, or there might be a letter missing. Toroid pressure. That's possible. I have definitely seen him write O's that look identical to his E's. So if you look up at the letter solar, or at the word solar here, toroid pressure would make sense. It wouldn't make sense. It makes sense as far as like the letters that are present. Like a coil, but I'm not sure how meaningful here. Toroids are just Warframe collectibles. Let's see. Toroids in solar panels for space. This ended up being almost more of like a space focus than the physics, but he's a physicist, so it still counts. Solar energy toroidal concentrators. And there are toroidal inverters, toroidal shells. All of these related to photovoltaics. So yeah, in solar power generators, there are toroidal concentrators that are part of the technology. So it would make sense that that word would be toroid. In mathematics, a toroid is a surface of revolution with a hole in the middle. The axis of revolution passes through the hole, and so does not intersect the surface. Thank you, Hannah. Fun missed fact. Read the novels. One part in Book of Atris involves Catherine making an age that's a toroid. That's awesome. Anyway. Sunburn as a weapon. definitely caught my eye. I wonder, like, I'm so curious. I wonder how much of this stuff is for his work as a professor, and how much of it is notes for writing sci-fi novels. Don't cross the streams. The best way to picture it, imagine you have a ring made of rubber. Imagine putting it on your finger and rolling it down, then imagine the motion it makes as it goes down your finger. Yeah, and we've had, there was an episode not too long ago, actually, that we looked at an entire toroidal-shaped space station design. Let's see, rocket, comet calculations. That would probably take a bit. Are there photos in here, I wonder? There's also the neighbor world, box 1, folder 20. Illustrations, folder 21. Synopsis and appendices. Ooh, that might be quick. It might not, but we're going to try. So Neighbor World is his unpublished novel. I'm not pulling the novel. I'm pulling the illustrations and the synopsis, because that seems useful. I think the folder numbers might be wrong, because that is not what's supposed to be in that folder. Yeah. Huh. The finding aid has these two folders reversed. It's an archival conundrum. Not really, but it's something that I will fix. The finding aid says that folder 22 is synopsis and appendices, and that folder 23 is Bikini of the Neighbor World. But what's actually written on the folders has it reversed. The easiest way to fix this, what I'm going to do when I get back to my desk, is I'm going to erase 23 and 22 and write the corresponding numbers so that they match the finding aid, and then put them back in here. But that would be the easiest way. But that changes the order. So what I'll probably do is I will probably go into the finding aid tomorrow and just update the numbers in the finding aid. That way they stay in the same order that they're in right now, because I don't know if that order had meaning for the author. So yeah, like, initial reaction is I should just erase the numbers and write the correct ones, but the correct ones should be it should be in the order that they are in the finding aid, because that, or the order that they physically are is what they should be. "1962 General Dynamics report on toroidal pressure vessels for space launch applications never says what those applications were at the time, but apparently it's a thing. And the report's just about how not to make them explode. Ooh, illustrations for, oh dear. These illustrations are in Mylar that wants to not show up super great on camera with the lighting. His sci-fi novels looked really cool. I don't know anything about them, but I'm always up for, like, well, this glove is on backwards, but it's fine. I just want to pull out at least one of these so that it can be viewed without glare. This is interesting art. I don't know, was he the artist? Because I'm jealous if he was, because, like, if he was an author, an accomplished physicist, and an artist, I'm very jealous. It doesn't have, there's no signature on it. So I don't know if, small atomic powerhouse on the Striemann Canal. The Striemann is one of several canals that carry water from the South Polar Cap to the seas. These are the only canals that carry water. This powerhouse supplies current for the railroad from which the picture was taken. The engineer looks worried over whatever is making the ripples in the water. So yeah. These are really neat. I don't see any like artist's initials or anything like that. Plowing in the Mars Erythraeum. Like the other seas, this one is an ocean, solidly frozen clear to the bottom because the average temperature of the planet is negative 40 degrees Fahrenheit. The ice is covered with wind-blown sand and with muck. It is plowed every year in the late winter and then becomes chocolate brown instead of green. Plowing the seas. That's interesting. Oh, that's cool. I'm gonna have to do some sort of blog post on this. This has been a learning opportunity. I'm taking notes on how to make a higher energy physics episode later. I mean, we get distracted easy. We find something interesting and we spend a lot of time on it. Martian Desert Canal from an altitude of 100 miles. The railroad runs straight from one center of civilization to another because the flat terrain gives it no reason to curve. The people build their homes and plant their crops within shopping distance of the towns along the railroad, while the backcountry is overgrazed. This makes the route of the railroad visible from the Earth. Interesting. Yeah, I'm gonna have to I'm gonna need to do a blog post and get some of this stuff on the internet so that we can investigate further. You're already jealous of writers who can also artist, but adding scientist is so much, and mathematician, because to be an accomplished physicist, you also have to be a mathematician. Physics is math. Synopsis. So we may not be able to go through the entire synopsis because we're hitting overtime now, but there's definitely not time to read the novel, but a synopsis, maybe. And yes, it is blurry. The actual document in person is blurry. It is not a camera problem. The Neighbor World, synopsis. Professor Wilbur Hunter is teaching physics at a small college in the province of New Brunswick. Here he meets John Kingston, the nephew of Sir Henry Kingston, the famous inventor. Kingston Rocket. So the Kingston Rocket book was definitely research for his novel. Fun story from that competition, my friend on another team tried to make a 2-stage setup. He inflated it. The first stage exploded, the second stage launched sideways and hit a girl in the face. It gave her so hard it gave her a bloody nose. That is, sorry, I missed the first post, which was, you moved to a new place back in early August and your neighbors all have a bunch of kids. You helped them build water rockets before school started. That's cool. Also, I'm sorry that it gave her a bloody nose, but that sounds like it was really fun to watch. Just possibly more safety precautions next time. Because failure of a rocket is as instructive as success, as long as you live through it. Here he meets John Kingston, the nephew of Sir Henry Kingston, the famous inventor, and the two become friends. Sir Henry writes to John that he is building a rocket to go to Mars and invites him to join the expedition. He suggests that John invite Professor Hunter also. They visit Sir Henry at his home, Green Isle. Here, Wilbur meets Sir Henry's daughter, Mary. The inventor tells them that he has already sent a small photographing rocket around the moon and shown them pictures that it took. He tells them that he now plans to take a large man-carrying rocket to Mars, become a satellite of the planet for a while, take pictures and examine it through telescopes, and then return to Earth. In addition to themselves, he plans to take Dr. McComb, the astronomer. Wilbur and John compare the knowledge to be gained by the expedition with the risks involved and study Sir Henry's plans in detail. They decide to go. Sir Henry takes them out to a mountain peak in Colorado, in which he has built the enormous gun from which the rocket is to start. Here they remain all summer, supervising the erection. In October, Wilbur and Sir Henry return to Green Isle to make tests of some of the instruments. Wilbur begins to realize that he is falling in love with Mary, but cannot make up his mind to propose to her before he has to leave Green Isle. They go to Washington to make the final tests of the accelerometers that are to tell them their speed. Here they're joined by Wilbur's sister, Eleanor. She asks many questions about the trip and suggests the use of the sign language for talking to the Martian people in case they have to land. I'm curious what her justification is for suggesting sign language. I'm not saying it's a bad choice. I'm just curious why she suggested it. A telegram is received telling of an accident to Dr. McComb that will render him incapable of going. Sir Henry tries to find a substitute, and as a last resort, takes Eleanor. Wilbur and Eleanor arrive a few days before the rocket is to start. John introduces Clark, in whom he was interested at the college, or Claire? I'm not certain. Claire, I think it's Claire, and who was now consented to marry him when he returned, inspect the rocket, and store their supplies and equipment aboard. Eleanor advises Wilbur to propose to Mary. He tries once, but is interrupted. Then he's unable to find another chance because of the crowds that have come to see them off. After the farewell dinner, Mary goes with them to the door of the rocket, and Wilbur kisses her goodbye. The rocket is successfully started and proceeds on its journey to Mars. There is only one adventure on the trip, which is otherwise very monotonous. That occurs when a large meteor passes very close to them at enormous speed. After 7 months, the rocket reaches Mars. Sir Henry slows it down enough to let it be captured and becomes a satellite of the planet. They study the surface and take pictures, but there are features they cannot quite make out. They decide to go still closer. For making the necessary reduction in speed, the oxygasoline jet is used. Wilbur makes a bad blunder in working it and sets the rocket on fire. They all take to the landing plane, abandon the rocket, and land on Mars. Morning finds them in a level desert at latitude 54 degrees south. Nearby is a meteor crater in which they bury the landing plane and such supplies as they do not need at once. They find honey mice and aerosaurs, Arissus. They kill one of the latter and find it good eating. While they are dissecting it, Eleanor calls their attention to a strange object on a nearby hill. Oh, Key Squared, thanks for stopping by. We'll be dashing off here soon. The synopsis is actually rather lengthy. So I'll leave it there with a cliffhanger. I will put this on my list to get the photos and the synopsis online. I don't know that the full manuscript will make it up there, but I will prioritize these. I'll probably end up digitizing them and then doing a blog post. So watch the Special Collections blog for those to come soon. Because I don't want to leave you with a cliffhanger that you have no way to solve because, it's an unpublished book. Strangely, though, it reminds me a little bit of, it's not identical, but it reminds me of the plot to an old video game called Martian Dreams. Here for the very end of stream. Hi, Puddle Glum. Yeah, we are sadly having to end. Like, I could sit here and just read that whole synopsis because it sounds like actually a decent book. I'd be interested to read it. I'm glad I helped solve what should I make for a blog post. Yeah, I have too many of those now. But thank you, Sterling. I don't mind having another one. And this one might actually not be too terribly difficult to get done quickly, which is good. Quickly is ideal considering I'm supposed to do a blog post next Thursday. Not tomorrow, but next week on Thursday. And since I'm out all of next week, I was going to try and get something done tomorrow. This one seems like it might be pretty easy to do. Let's see. Coming up 2 weeks from now, the first Wednesday in October, we have Robert Eldred Taylor, who I know there's like draft stuff. Is that one? I think it's that one. I'm looking. Yeah, it's the draft. So I misspelled it, and it's fine. Anyway, World War II. We have documents from someone who was initially not permitted to join up because of some vision issues, but then they were being required to register for the Selective Service. So we've got Selected Service records, was disqualified from avian cadet training due to color blindness, entered the enlisted reserve corps, and was assigned in inactive status to Pan American World Airways in Miami, Florida. But then in 45 had to go in front of Selective Service Board again to be considered for duty. And we've got a set of documents related to all of that, a bunch of the Selective Service records. They're really, really interesting. I've actually had a chance to see these. This was one of the collections I had pulled for the World War II episode that we did recently, and we just ran out of time. And so it's getting its own episode. It should be awesome. Oh, I can definitely figure out how to make a one-folder collection last the whole time. That won't be a problem, especially not with that collection. Anyway, let's see about a raid. And just as a reminder, I will not be streaming next Wednesday. There will not be an Archival Adventures next Wednesday because I have taken the entire week off. So the next episode will be the first Wednesday in October. Options for raids. We've got Shark Cam. But you know, we've done the aquarium and NASA recently. It's been a little while since we've popped in and said hello to Stephen Joyce. And so I think we're going to go over there today and just say hello to the wonderful Stephen Joyce. Stephen is an absolutely wonderful streamer, wears tiny hats, makes them, has a lovely community. There are quite a few librarians, and is just an absolute joy. So please join me as we head on over there. I have to type. There. And but yeah, thank you so much, everybody, for joining today. Thank you to my mods. Thank you, Hannah, for the help dropping commands in chat. Thank you, Sterling, so much for the work that you have been doing to help prep these episodes. It is certainly helpful for me. And yeah, thanks everybody who showed up today and hung out and had knowledge to share and clarification to provide regarding things like the physics calculations that we encountered, because you knew what the variables were and you knew what we were looking at, despite lacking any sort of like units of measure. So you all are awesome. I appreciate all of you so very much. Thank you for joining me. I hope that you will be back soon for another episode of Archival Adventures. Until then, keep exploring history.